right, good afternoon, everyone. I'm going to get started here with the 100% outside air system, talk a little bit about dedicated outside air. We're starting here with a great screen picture of the CRDCV unit. This is a 100% outside air heating and cooling unit, which we'll talk about later on. But just to get started, I'll show you what we're going to go over today. Basically, we're going to talk about what is a DOAS system or a DOAS system. It's commonly called. Why would I use one? Where would I use it? What applications do I have for the unit? And also, what are some of the features of the unit, and how can I use a DOAS system to contribute to lead points and certifications for local codes? So if we get started, actually, what is a DOAS unit? Basically, it stands for a dedicated outside air system. Basically, this unit is a separate unit dedicated strictly to the management of outside air. So what this actually does is, because we're just handling the outside air or ventilation air, we're actually decoupling that load of heating or cooling the ventilation air from the heating and cooling of the space load. So that decoupling of those two systems is the key behind this unit. So what makes, sometimes people get confused between a makeup air unit, an outside air unit, a standard rooftop unit. So what's the difference between all these different types of units that we can use and integrate into our building? The difference basically between ventilation air, makeup air, and load tempering air. So if we're going to look at the difference between each one of those systems, what makes a dedicated outside air system different from a makeup air unit or rooftop unit? Well, a rooftop unit is handling just the heating or cooling load in the space. It's typically designed for 100% return air. Obviously, you're going to have your economizer mode for free cooling and things like that. You'll have some outside air, but typically the design is for 100% return air to handle the heating and cooling load inside the space. The makeup air unit is obviously providing makeup air. It's typically designed for an 80% return air with up to about 20% of outside air taken into consideration there. A dedicated outside air system provides strictly ventilation. So this is actually 100% outside air with no return air integrated. That just gives you a brief definition of the difference between some of the systems. But just to go a little farther, what's the difference between makeup air and ventilation air? Because this is the key between the design of the system. Makeup air generally replaces air exhausted from a space due to a process, an application, or positive displacement, things like that. So you're talking about kitchens, industrial applications, anywhere where you have to design based on air changes per hour, bringing in that fresh air to make up the exhausted air. Differently, ventilation air, as prescribed by the ASHRAE Standard 62.1, which is laid out for ventilation for acceptable indoor air quality, is basically just that. It's ventilation to provide indoor air quality for the system. It's not related to any exhaust air. So we're not making up exhaust air. That's a completely separate system dealt with by the makeup air unit. The dedicated outdoor air system is strictly for ventilation. So basically, a dedicated outdoor air system is a standalone system. This is an independent system that can provide heating for that outdoor air, heating and cooling for that outdoor air to be able to bring it directly and comfortably into the space, meaning that this unit is most likely a typical integrated unitary package product. It's fully capable of tempering that air, so it incorporates some type of heating source, most typically an indirect source. You're not introducing combustion gases, natural gas heating, and then multiple different types of coolings you can incorporate, DX cooling, chill water, evaporative cooling. We've also started incorporating VFDs and energy recovery wheels to enhance the efficiencies of these systems. So when exactly would you use a dedicated outside air system? Basically, we're looking at using these systems whenever you have a large enough amount of ventilation where you're concerned with having to heat or cool it. When you have so much ventilation air coming in that at a negative 10-degree day, you have to worry about bringing that air, tempering that air to a comfortable level to bring that into your space. So what type of spaces do we run into that? Everything you see here: malls, classrooms, offices, auditoriums, school gymnasiums, aerobics, gyms, things like that, restaurants, strip malls, retail facilities. So any of these applications, you have a large amount of people coming in, a large amount of CFM for ventilation requirements. So what is that dedicated outside air unit going to do for those spaces? What's it going to do for a gymnasium? Well, first of all, it's going to help you attain the ASHRAE 62.1. but it's also going to give you better space comfort because, like I said before, we're decoupling or separating the ventilation heating and cooling requirement from the building heating and cooling requirement. In addition, we're also going to get more effective treatment of the ventilation air. So we're going to get better filtration of that outside air that we're bringing in. The intention is to improve indoor air quality, provide enough breathing air for the people, and increase the air quality. So we want to get that filtration up to a MERV 15 filtration possible with these systems for the outside air coming in. And also this unit is going to contribute toward a LEED certification of your building as well. There's multiple points that a DOAS unit can contribute to, and we'll talk about those as well. If we look at the typical ventilation requirements for certain applications that we just discussed, like classrooms and offices, restaurants, if you look at like a health club, they lay out as a recommendation 22 CFMs per person of outside air ventilation. And they lay out maybe an average of 40 people per 1,000 square feet. So let's say if we look at the health club, let's say we have like a 4,000-foot health club that you're designing. Well, a 4,000-foot health club at 22 CFMs per person, do your short math, it's a little over 3,000. It's like 3,500 CFMs of just dedicated outside air ventilation into your system. Now, that's a lot of air that you have to be able to heat and cool and temper it so you can bring it in. So this is a great application where we would look at a dedicated outside air system. And we would have to do that because if you look at conventional equipment, like a conventional rooftop unit, these units aren't made to bring in that amount of outside air. First of all, the heat exchangers and burners, they're not designed for fresh air. And also, you'd have to size that rooftop equipment not only to handle your space load, but then you'd also have to design it to heat and cool that 3,500 additional CFMs of just ventilation load. So now you're oversizing your system, and you're not getting proper cycling on your actual heating and cooling loads. So it's just not a great design to incorporate that, and that's where these DOAS systems come into play. If we look at that same application, a single DOAS unit can do, an office of 288 people, or a restaurant that's 7,000 square foot. So we're looking at a single dedicated outside air unit. One unit can handle the ventilation for each one of these spaces. A single college classroom that's, 612 people. One single unit can handle that versus multiple rooftop units trying to handle that ventilation load. So we're talking about less roof penetrations with a single unit and a few other advantages which we'll talk about. So here's some of the other advantages on using a dedicated outside air system. It's going to simplify your design process because we are, like I said, decoupling those two load requirements. We're separating the internal load and the shell load of the building, those heating and cooling space requirements, from the ventilation air requirements that we have to heat and cool. There's not the same concern with the VAV application, where you never know exactly how much outside air is getting to your space. With a dedicated outside air system, you always know exactly how many CFMs are getting to your space. Like I said before, this is limited roof penetrations into your building with a single dedicated system. And this is also going to help with your 62.1 compliance and getting LEED accreditation for your building. One other additional reason is a dedicated outside air system integrates perfectly with other HVAC systems, specifically the VRF system. VRF system uses refrigerant lines to do their heat transfer and does not incorporate ductwork. And basically, these systems are designed for just the heating and cooling space load requirement. They don't incorporate ventilation. So this is a perfect opportunity to have a separate dedicated system. That way, this heat pump VRF system, which operates at very high efficiencies, can also work in tandem with the high-efficiency ventilation system when you have that requirement. So it's a great tandem system for this type of application. If we looked at, so we've got our dedicated outside air system, how are we getting that fresh air to the space? And there's a couple different ways. You've got a destination. You can take fully tempered outside air directly into your space, or you can take untempered air, if you're using free cooling, directly into the space. Or we can take that tempered air or untempered air to a terminal unit or a heating and cooling unit, an air handler or a terminal, and then distribute that to the space. So if we look at a system delivering directly to the space. We've got our outside air unit on top, our dedicated outside air unit, delivering tempered air directly into the space. And you can see that there's a separate heating and cooling system in that space to handle that space load requirement, those internal gains. We can also take that dedicated outside air unit into separate terminals recessed in the ceiling, or VRF terminals that have outside air openings that can bring air directly into the space. Here you'd be mixing some air with return air, so you could actually modulate your outside air heating requirements. You can bring in some more, probably colder or less untempered air if you're going to integrate that with your return air in your terminal units, but you'd have to accommodate that with the terminal units. They would have to be able to heat and cool that extra ventilation load. Or, as we mentioned, you could just fully temper the air and bring it into the terminal units and use that as your distribution device. So if we take a look specifically at some of the product offerings of a DOAS unit, Sierra has a DCV unit. That's the picture we saw before, and it's an integrated packaged unit. And it's a great way to do your cooling and your heating of your outside air, as long as getting a high-efficiency filtration for it. It's also going to contribute, like I said, towards the LEED NASH rate 52.1, which we'll talk about. It's a rooftop system. This actually is an indirect fired system with a DX condensing unit with the R410A pure-on refrigerant. We'll talk about the turn-down ratio of the burner, and also include the patent-pending Adapt-Air DDC control system. And this DDC control system is phenomenal because it'll integrate with most front ends or other control systems. So your Modbus, your LAN, your N2, LANWorks. So this will communicate to all your other systems as well. Some of the key features of this unit is the pure-on refrigerant, the ability to add electric heat, the fully integrated digital controls, open protocol, incorporation of an energy recovery wheel, VFD options to modulate all the fans and the blowers. They've now incorporated a digital scroll compressor as an option for these units to get extremely high turn down on your cooling as well. And then they also have a DHT TD burner, a digital high turn down burner, which we'll talk about in detail a little bit. This is a key feature to this unit that makes it so efficient. The DHTD burner is actually a digital high turn down burner, patent pending through MESTEC, the original company, and it's a drum and pass tube heat. It's a two-pass drum and tube heat exchanger, which is actually a lot more efficient than your standard clamshell heat exchanger. And basically, the fuel and combustion airflows are synchronized using digital technology. So both the airflow and the blowers and the heating is all synchronized, and they can actually turn down up to 99-to-1 turn down on some of these systems. So you've got a high turn down. So it's the ratio of your BTU input to the maximum firing rate of the BTU input to minimum firing rate. That's your high turn down. That's your turn down ratio. But since the heating load application varies with the outside air temperature, you're bringing in, let's say you're bringing in a constant ventilation stream, but the temperature of that ventilation, the temperature of that outside air is going to vary. So we're still bringing in a constant amount of airflow, but the temperature is going to vary. So we have to be able to modulate with that temperature while meeting the same CFM requirements. So that's basically what this digital module does. It actually turns down the burner to match those temperatures. In some of the sizes of the cabinets, we can actually go, on the size 20, we can go a 33-to-1 turn down. On the size 40 cabinet, we can get a 66-to-1. And then on the size 60, we can actually get a 99-to-1 turn down ratio on the burner. You take that and compare that to, like a typical burner that has 2-to-1 turn down. I mean, we have 99 stages of turn down versus 2. So this is it's a really high efficient system and a great way to do ventilation, which is traditionally an inefficient part of a building design. The nice thing about the DHTD is it's a linkageless operation. And, basically what that means is we're not coordinating our airflows. Usually a mechanical linkage system is based on an actuator, so you have your valve and then you're cut off to the blower. And these two things, the gas valve and the blower, can actually get out of sync, and therefore you're not matching your inputs. And they can actually get out of phase. And so what this does is this is a linkageless system, so it eliminates that. It eliminates the hysteresis, so you're not cycling your system or jumping up on your loads, and your efficiency is not compromised. And there's no additional field setup for the system, so that's really nice. Some of the other benefits are you get a closer temperature control. Like I said, you eliminate that hysteresis, that bouncing all over of your set point temperatures. You're reducing cycling because you're modulating down and operating for a longer time, and you're not cycling your system. You're going to get longer equipment lifetime because you're running at a more constant speed on your blowers and your compressors, reducing your cycling. Everything is going to be more high efficient because we're using VFDs to modulate. We're actually matching the baseload temperature. And obviously that's going to turn into a lower operating cost. This chart right here is a really great chart to look at. If you look at the red line, that's a low turn down burner, maybe a 2-to-1 turn down burner. And if you look all the way to 100% efficiency, that 2-to-1 is at about 80%. What is that? 81.5% at 100% BTU input. And as you go down the percentage of input, down to 50% and down to 0, you can see that the highest efficiency that the 2-to-1 is going to get is 82%. And that's about where the digital high turn down ratio burner starts. This burner can get all the way up to 89.5% efficient. So it's a really efficient system. And that's going to directly correlate to the cycling. So this little chart, I like to show this little chart because it shows how many hours that a typical system is actually going to cycle on and cycle off to meet that load temperature. I'm sorry, the ventilation temperature. I want to make sure we're specific on that. So if we look at Chicago, Illinois, the average heating hours, 6,700 heating hours a year. If we look at the comparison between the digital turn-down burner and the 2-to-1 turn-down burner, we can actually see the amount of hours that we're cycling on and off. So if we look at the 2-to-1 system, I mean, almost 66% of the time we're actually cycling the system, compared to 2.4% with the digital turn-down burner. So it's a significant amount of time that we have cycling the system on or off, not mitigating the not mitigating humidification. So if we take all those advantages of the dedicated outside air system and we look at the code and we look at leak qualifications, there's a lot of points that you'd actually apply for through this unit. We're going to take a look at each one of those briefly. Let's look at ASHRAE 62.1, which talks directly about indoor air quality and ventilation. There's 5 different points that we've bulleted here that we're going to take a look at. So airstream surfaces, section 5.5. The unit we can easily design in a double wall construction, different types of insulation, open face, antimicrobial. There's multiple different types of insulations that you can incorporate to qualify for this or to help you comply with the section 5.5. Particulate matter removal. The unit has a 30% 2-inch filter that's a MERV 7 rated. 62.1 actually has a minimum of 6. So this unit comes standard with a MERV 7 filter. But the nice thing is that you can actually incorporate up to a MERV 15 filter into this system and design that in. So you have a huge range of filtration options. The humidification of the system. If you look at a standard rooftop system, they'd have to have up to an 8-row coil to be able to dehumidify a system. A 62.1 requires a maximum of a 65% relative to humidity rate. And like I said, this unit is just a 4, 6, or 8-row coil. The extra chill water can actually meet and keep below that 65%. So that's something that very few rooftops can even do with a 4 or 6-row coil. Got all thin tube coils on these systems. They're designed to less than a 3/4 of an inch inch water column pressure. And this is, in accordance with this unit was actually designed in accordance with 62.1. And that's basically the summary of these few slides. Most outside air systems were a makeup air unit that was modified to qualify as a dedicated outside air system. This Sierra DCV unit was actually designed as a dedicated outside air unit based on 62.1. So that's why there's so many different points that qualify or that help you comply with ASHRAE. The unit has full-size gasketed doors and all key components. You can actually see that the labeling of these units is put on multiple panels, and each panel is hinged for access. Additional feature. Great for servicing as well. So if you look at LEED for new construction, there's multiple points that apply to these units, dedicated outside air units. So we have the additional outside air, efficiency and filters, controllability, verification, refrigerant, and measurement and verification. So we'll go through each one of those briefly. Because with these systems, we're increasing the amount of outside air to at least 30% above 62.1. You can earn a LEED credit just for that by increasing the amount of ventilation a third. Like I said before, a standard rooftop unit is not made to handle that much outside air, so it's typically not attainable with a standard rooftop system. The unit has the digital high turn-down burner, which we talked about in detail, so we can get as high as a 99-to-1 turn-down ratio, and that's a very low heating energy consumption. So and the LEED states that any buildings that operate 10.5% lower than ASHRAE 90.1 standard can earn a LEED point as well. So that's an additional point. The unit can accommodate up to, accommodate 12-inch high-efficiency filters as high as a MERV 15 rating. And LEED states that using a MERV 15, using filters of MERV of at least 13 will earn an additional LEED credit point. So you can exceed that as well. The unit is designed and selected using coils intended for, the 410A operation. I know the refrigerant management credit has changed a little bit, but you can contribute up to 2 points as far as refrigerant management. And then we also have the open protocol board, so you can tie into any of the other front-end systems that we talked about before. And then the standard adapt air DDC controls that come with the unit can also qualify and should be mentioned to the LEED AP in the project for verification and controllability of the amount of CFMs that's going into each space. So you're actually reading the CFMs into each space, and that's where it's going to contribute. So that's a summary of the LEED credits. Just a quick, brief summary on some of the additional Sierra systems. If you look, there is a dedicated outside air system for splits or chill water applications. It's an indirect fired system. That's the ZFR model. They also have a direct fired heating system. We have an evaporative cooling system for outside air up to 80% saturation efficiency, which is phenomenal, and that'll translate to a lower operating and maintenance cost on the system. The Aztec unit is an indirect or direct fired evaporative cooling system. So you can see there's an additional cooling tower built onto the end of that unit. It's basically a multi-stage rooftop mounted evaporative cooling system for makeup air and for ventilation. It can provide up to 119% saturated efficiency, which is phenomenal. We scroll down, and that's basically a summary of the dedicated outside air systems for today. If we look at our webinar schedule going forward here, we've got next Monday is actually Memorial Day. So we are going to not have a webinar next Monday, but on Monday, June 7th, we will have a webinar on the Carrier AquaZone water source heat pump. We always like to mention our additional training facilities at TEC with HVAC Solutions. We do the webinars every Monday at noon. We also have multiple different presentations that we can do. We have the hands-on technical lab in our Melrose Park facility. We have our mobile showcase truck that we can bring in. It's out to you, your customers, designers, engineers, to actually see pieces of equipment and kick the tires on that. So there's a lot of different classes available as well that you can request from us. So that's in summary. So I'm going to open up and see if you guys have any questions on dedicated systems. I'll give you guys a few minutes. I thank you for joining in with us today and see if you have any questions.